Hello calculus students and general seekers of truth. In the previous videos we have worked out the derivative of natural log and done some examples using log properties, and now we will take the derivative of exponential functions, and we're going to do this using the derivative of natural log as well, along with a little bit of implicit differentiation. If you don't know what implicit differentiation, at this point you should stop this video and go ask for help and then return. If you do, then we can continue. So for number 4, instead of taking the derivative of h prime immediately, what I'm going to do is just rewrite this as y is equal to 3 to the x, just keeping in mind here that y is a function, okay, and that's going to matter when we go and take the derivative. Then I'm going to take the natural log of both sides. So natural log of both sides. So what I can do then, when I do that, is apply the power rule of natural log and just pull the x down to the front. And on the right side here, I still have natural log of y. Then I can actually now take the derivative. Okay, so taking the derivative of both sides, on the right side it's much easier, because if you notice here, this is just a linear function. This here is actually a constant, so this is natural log of 3 times x. The derivative of that is just natural log of 3. And on the left side, I have 1 over y, because that's the derivative of the natural log, times, and remember that y is a function, so we have to multiply it by y prime. And in fact, y prime is what we're looking for. So we're going to isolate y prime by multiplying both sides by y, natural log of 3 times y. However, what was y equal to? Well, it was equal to 3 to the x, so I can just say that y prime is equal to natural log of 3 times 3 to the x. Okay, and that's the derivative of 3 to the x. And there you have it. That is the solution to that problem. Okay, so to review, just looking back, the main idea here is, rather than just taking the derivative directly, we make an equation out of it. We use the properties of natural log to help us simplify the derivative process, and the trade-off is we have to multiply by y at the end. But that's not a big deal, because y in this case is a fairly simple equation to begin with. Alright, so I'm going to continue with a couple more examples. So just like before, I'm going to say that y is equal to, I'm going to set this is equal to y is equal to 4 to the x, and just keeping in mind that y is a function. Okay, that's very critical to remember. Take the natural log of both sides, which is equal to the natural log of 4 to the x. Then take the derivative now, the derivative of, well, I'm sorry, not the derivative yet. I'm going to pull the x out to the front. Okay, so this comes down to the front. That's the power rule of logarithms. And now I can take the derivative. Derivative on the right side is just natural log of 4. Derivative on the left side is 1 over y times y prime. And we will try to get y prime by itself by multiplying both sides by y. So now on the right side I have the natural log of 4 times y. But remember once again that y is equal to 4 to the x. So y prime is equal to the natural log of 4 times y, which is just 4 to the x. And once again, that is my answer. So same idea, just as what we had before. So in number 6, we are going to take this derivative of 3x times 4 to the x. Now, you have to resist the urge sometimes to rewrite this and use implicit differentiation. Sometimes you might not need to. For example, in this case, all we really need to do is apply the product rule. We have 3x times 4 to the x. So those are our two products. So that means the derivative is the derivative of the first factor, which is just 3, times the second factor, so that's 4 to the x, plus the derivative of the second factor, 4 to the x. Well, this would seem difficult, except we figured it out already. So this is natural log of 4 times 4 to the x times the first part. Now what we can do is a little bit of additional factoring. We can factor out 3 and 4 to the x, 4 to the x and 3 there. So we're going to say 3 times 4 to the x, parentheses, and what do we really have left? Well, we have 1 plus the natural log of 4 times x. Okay. So once again, many people get into the flow or the rhythm of using the natural log properties to find these derivatives, and they oftentimes cause a greater mess for themselves. And so the key and the moral to take away from here is, well, we have to think about every problem. If you already know these derivatives, then there's no need to take any more to use the natural log properties. Okay? And maybe this begs the question, well, how do I know the derivative of 4 to the x, or 8 to the x, or 20 to the x? Well, whenever in mathematics we have a problem or a certain type of problem that we keep seeing over and over and over again, what we do is we add a layer of abstraction. At least that's what I call it. So we're going to return to the top here and solve problem number 7, which is a generic simplified version of number 4 and number 5. If you notice here, 4 and 5 are the same problem, it's just with the constants is a little bit different. So we're going to find the derivative of any constant raised to the x once and for all. Alright, so just as before, we are going to take the natural log of both sides. So I have the natural log of y is equal to the natural log of a to the x. Then I can apply the power rule of logs and say x natural log of a. Then I can take the derivative of both sides, and I get the 1 over y times y prime is equal to natural log of a. Because once again, what's on the right here is a linear function. Natural log of a here is still a constant. So y prime is equal to the natural log of a times y, which means that y prime is equal to the natural log of a. But what was y equal to begin with? Well, y was equal to a to the x. So that's just that. Okay. So the derivative of any exponential is nothing more than the natural log of the base times the original function. So you can see in the previous examples, the derivative of 4 to the x is nothing more than natural log of 4 times 4 to the x. The derivative of 3 to the x is nothing more than the natural log of 3 times 3 to the x. Now I do have to caution you that if we had some more complicated expressions here besides x, then the chain rule will have to apply. And we'll look at that in our next video. Thank you for watching, and have a wonderful day.